Hello and hope you're doing well. Welcome to a Coder's Journey. This would be the final episode of this series where we are exploring Recoil. In this episode, I have decided to talk about persistence and performance and optimizations with something called atom effects. So if you've followed the previous episodes, you are now ready to connect all these ideas into a more production-ready state management setup. Initially, I wanted to, record up to 10 episodes for this series, and then I decided to wrap up the series, with this final episode because we have other state management libraries that you can learn, things like Mobix, Zustand, Jotai. So make sure to watch those playlists as well. And there are other, topics that we need to explore. So I think for this episode, for this series, 5 episodes will be more than enough probably. And if you want to dive deeper into the different concepts of Recoil, you can probably study the documentation, and I don't know, maybe in the future I will also publish some other videos as well. The goal of this episode will be to talk about atom effects in Recoil. So we're gonna, implement persistent state using local storage with this, concept, atom effects. And if you want to, know more about effects in React, I have already created another playlist that you can watch to understand everything there is to understand about hooks. Hooks are used when you want to execute side effects, right? The same thing applies here when it comes to atom effects in Recoil. First, let's talk about it. Let's understand what we want to talk about. So atom effects is the topic of this episode. And the idea is that in Recoil, an atom effect is simply a function that runs when an atom is created, and also whenever its value changes. So think about it. You've got the ability to run some piece of logic whenever an atom is created or whenever the value changes. So you can think of it as a lifecycle hook, but specifically designed for atoms. It is similar, in concept to useEffect, which is another hook in React, but instead of working at the component level like useEffect, it operates at the global state level, directly inside atoms. Now, to implement things, what I'm going to do is to, create a file called local storage effect inside of a folder called effects. In my Recoil folder, I'm going to create this effects folder, and then inside of that, I'm going to add this local storage effects.ts. And then as you can see, I'm running the app, right? Let me show you something. Right now, whenever you start adding tasks and then you refresh, everything is going to get, wiped out, right? So we want to change that. We want to persist, the atoms or the tasks that we've got in the application using this local storage effect. So let's go ahead, write the code, and then we will, talk about the syntax and everything there is to know about this. So let me import atom effect first. And then I'm going to create local storage effect. The syntax might look a bit scary initially, but I'm going to explore everything here with you so that you better understand what's going on here. So let's do our console warning. And then the next part. And then finally, we're gonna save everything. Let me zoom out a bit so that you guys can better understand what's going on. So let's take a look at the code. It is not that difficult to understand. As I discussed, this effect is responsible for connecting an atom to local storage so that the state can persist across page reloads. So the atom effect, as you can see, this type means that this effect is generic and can work with any atom type. It can be used with strings, numbers, objects, or arrays, making it, highly reusable across different parts of the application. Then you've got this, T, which basically is the generic type. which allows this effect to be reused for any atom type without rewriting the logic. And then you've got the key as well. So the key parameter is a string that represents the local storage key under which the data will be stored. And then the return type, which is atom effect of T, indicates that this function returns a recoil atom effect. So the core of this implementation is the effect function inside of that kind of receives an object containing set self and unset, which we are going to discuss, and then recoil provides this object when the effect is executed. And internally, it includes additional utilities such as a trigger and node, but in this case, we only use set self and unset. So first, let's talk about set self. We have used set self here. So we're initializing the atom, right? Take a look at the code. We're reading something from the local storage and we are initializing the atom. So basically, set self is used to manually, set the initial value of the atom. So it allows you to bypass the normal state update, the flow, and directly, initialize the atom with an external value. In this case, it is used to, hydrate the atom with data coming from local storage. You can think of it as a way to initialize an atom from an external source before the application even renders. Then you've got, now let me, by the way, check. Okay, the error went away. So the next one is unset. So set self for initializing the initial value, and then we've got unset. Unset is a subscription mechanism that runs every time the atom value changes. So it allows you to react to state updates and perform side effects. In this case, it is used to synchronize the atom's value with local storage, effectively, keeping both in sync, the value we've got in local storage and the value inside of our state. And there are different things that are happening here. So, when the atom is initialized, the effect first reads any existing value from local storage using the provided key here, right? So we're reading that. And then if a saved value exists, set self kicks in. It is used to initialize the atom with that value. This means that recoil state is immediately restored from previous saved data. At this point, the state might look like a persisted object, such as, theme, which we can set to dark, for example. And then we subscribe to changes. So after initialization, the unset, as you can see here, is used to listen for any changes to the atom. So this function is triggered every time the atom value updates. It receives three parameters, as you can see. We've got a new value, we've got the previous value, which we are ignoring here, and we've got a Boolean called isReset, which indicates whether the atom was reset or not. So when isReset is true, take a look at the code. When it is true, it means that the atom has been reset to its default state. So the corresponding local storage entry is kind of, removed here. And when it is a normal update, the new value is serialized and stored in local storage, as you can see here, under the same key that we got, here as our input. So what I want to talk about now is to, give you a picture of the full life cycle. Let's walk through this and understand how this behaves in a real application. I'm going to put the steps here so that you better understand. So the first step is that your application starts up, right? Starts up. When the application starts, the atom is created and the effect runs. So it reads, from local storage and calls set self if a value exists, and then the atom is initialized with the persisted state. Then user updates state. So I'm going to write state update. So when a user updates the state by, for example, creating a new task, the atom changes and unset is triggered. And the new value is then saved into local storage, keeping everything in sync. Then the user might reset the state. So if the user, kind of resets the state, the atom has to return to its default value and is reset the, item here, right? The input parameter here becomes true. And in this case, the value is removed from local storage to prevent stale data from persisting. Now let's go ahead and update the task list atom. So I've got this task list atom, task list state, this one. So as you can see, we've got the key, we've got the default value. We want to update this so that it becomes, persistent across page reloads using that local storage effect that we just, created. So what I'm going to do is I'm going to add the, effects part here. And of course, I'm going to have to import this as well. So let's talk about the code a little bit. We're using that, atom effect that we just created, local storage effect, inside of the effects array of the atom. So we're also passing the key task list to it, which defines under which local storage entry this state will be saved. So this means that every time the task list changes, for whatever reason, Recoil will automatically synchronize the state with local storage. At the same time, when the application loads, the effect will restore the saved task and hydrate the atom before the UI is even, rendered. Now, if I run the, application, and if I start adding, some different tasks, and if I refresh the application, everything is lost again. Let me pause the video, fix the issue, and then continue. So what I did was to stop the application, and I ran the application again using npm run dev, and now everything is wired up. So probably, we needed to restart the app for whatever reason. So as you can see, I now, refresh the application and everything is persisted. I'm going to show you my local storage as well. So this is my local storage, as you can see, and the task list array is persisted here. So take a look at the different, tasks that we have created. So the state is, kind of persisted into my local storage. Let me close this one. And that was it for this final episode of our Recoil tutorial series. I hope you've enjoyed, the journey, and now you have a solid understanding of how Recoil works in real applications. As I told you, I wanted to record, more videos for this series, but because we have other stuff to also learn about, like other state management libraries like Zustand, MobX, Jotai, and so on, I decided that I would wrap up the series with 5 episodes. If you want to dive deeper, there's always the documentation. I will probably, from time to time explore other specific concepts. If you want to learn more about React, remember to check out my other, playlist on Zustand, MobX, Jotai, and other state management libraries. If you enjoyed the series, consider subscribing to the channel, give this video a like, and see you in the next playlist. Bye-bye.